Is that the
Exactly.
rules?
Alright, what questions do we have from the homework?
It will be. Okay.
How to work the tangent on my.
No, don't go all the way to the end. Let's
How to work the tangent on your
Yeah,
calculator?
because when I do it on my phone, watch it work now. No. See, it's 8.33, but it's actually. And that's the answer.
So here are your degrees.
Oh.
Here, by default, your calculator is in radians.
Oh.
Okay, listen, those of you with the 84s and 83s and stuff, by default, you are in radians, okay? So hit mode, get to the right mode. Those of you with the Nspire, actually it by default does degrees.
Oh really? I have to put little degrees on.
You do?
Yeah.
Okay. You have to look at the setting, but actually if you hit the little pi menu thing, there's a thing where it has a degree, or it has a little r. So if you want it to be in radians, just put the little r after it, and it'll convert it. It's kind of nice, because you can go back and forth between problems without having to switch modes every time.
Oh, so I have to switch modes every single time?
Yeah, you'll have to switch. If you have the 83 or 84, you'll have to hit mode, go in, change it from radians to degrees. So.
So can you do like question D, 43D?
Okay, so 43D. Yeah, this is the right section. When you're looking at these ones here, it says use the given function values and the trig identities to find the indicated trig functions. So we're trying to find cotangent, okay, and using our quotient identity, since we were given sine and cosine, our quotient identity says that the cotangent of any angle, in this case 60, is going to equal cosine over sine.
It's 1 over square root of 3.
Okay? We learned that tangent equals sine over cosine, so cotangent would equal cosine over sine. So our cosine was 1 over 2. Our sine is root 3 over 2. If we reduce that, that equals 1 over radical 3, which is root 3 over 3. Okay.
Can you do
How do you do D?
45D?
Yeah, but how do you do 30?
Oh wait, hang on a
I
second.
just have a question. If it's 30 degrees, you can divide by
Hang
2.
on. Let's take one question at a time. Alright,
You can go this
we'll look at 45D. Since you had a question on 43 still, we'll start with that one. How do we do ones that have to do with the 30-degree angle?
Do we just divide by 2?
No, you can't. And guys, listen, that's going to be a common temptation, alright? You're going to want to say, well, if the cotangent, or if the sine of 60 is this, then the sine of 30 must be half of that, right?
Sin 30 equals cosine
It doesn't work that
I
way.
just plug it in.
Sin 30 equals cosine 60.
Yes, sine of 30 equals cosine of 60. What identities were those? When the angles are complementary?
Your complement
No, the,
equal 90.
I don't understand this.
What?
If you add them equal 90.
If you add them together, they equal 90. 30 and 60 equal 90, but we said the sine of theta equals the cosine of pi over 2 minus theta, or the sine of 90 minus theta.
We're talking about the square of like equals 1.
Did we get here with you guys?
No.
No.
Oh, that's why. Okay, that's why you're stuck on that. Let's take a moment here.
We were still doing the Pythagorean.
The
We
Pythagorean-
finished up the Pythagorean. We finished up the
did two of
Pythagorean.
them. We did the last one.
Yeah, what we did.
Well, we had, okay, we had sine squared plus cosine squared equals 1. Then you divide everything by sine, and you get 1 plus cotangent squared theta equals cosecant squared. Okay. if you take this and divide it all by cosine, you get tangent squared plus 1 equals 1 over cosine is secant, so it's secant squared theta. Alright, so those were our Pythagoreans. Okay. So with you guys, we didn't get to
No,
What do you do for the
the
last one?
we did
cofunctions.
not see that. No.
What
Okay.
did you divide by for the third one?
For the third one, you just divide everything by the cosine squared.
So,
For this one, you divided all of this by sine squared.
Oh, okay, so.
For the last one, I think we said it, but we didn't actually write it all out.
Got it.
For the last one here, we divide everything by the cosine squared. So sine squared over cosine squared is tangent squared.
So those are the three?
Those are the three.
yeah, we did that one.
Okay.
That's
I
that's
think
where
we at
we
least said it. If I didn't write it down, I
No,
would
you
have
wrote
said
it
it.
down.
No, this is where we ended yesterday.
Okay.
This.
So let's make an observation here. I'm not going to develop the whole thing, but you can actually see this relationship, and this is probably why you guys didn't know how to do that one. I forgot, we didn't get to this. If you look, we saw with the 30-degree angle and the 60-degree, or pi over 6 and pi over 3, the coordinates just reversed. And then with the 45, the coordinates were the same. And we saw then, or we can see then that if we have the sine of 30, that's a half. Well, so is the cosine of 60. If we have the sine of 60, that's root 3 over 2. Well, that's the same as the cosine of 30. Okay? So we saw here that if the angles add up to 90 degrees, then the sine and the cosine are going to be equal. Okay? Now, we could take a long time developing and expanding this to include other trig functions and not just complementary angles, but here's the basic principle that you need to know. Okay? The sine of theta is always going to equal the cosine of pi over 2 minus theta. Okay? Sine of theta equals cosine of pi over 2 minus theta.
Can we just put 90 instead of pi over 2?
You could put 90 if you want, but you need to be able to recognize it either way.
Okay.
Okay?
Is this something we're gonna have to like apply?
Yes, we'll use this. In fact, that's how we got on this topic, is someone asked how do we do D, and how do we find the sine and cosine of 30 if all we know are the sine and cosine of 60?
So then you'll just use these.
Okay? You would use these, alright? So let's finish looking at each of these. Alright? If you look, like if you're doing some searching on your own, you may see these written as theta minus pi over 2, or theta minus 90 instead of the way I have it written. It actually makes no difference. Okay?
So they're interchangeable, sine and cosine.
Yeah. So sine theta equals cosine of pi over 2 minus theta. You could also say cosine of theta equals sine of pi over 2 minus theta. Alright? Then this also works for secant and cosecant, and it works for tangent and cotangent. These are called the cofunction identities because they go together, sine, cosine, secant, cosecant, tangent, cotangent. Alright? So those are the three cofunction identities.
Wait, why are those ones in a box? Like what makes them different?
Those are the three. I mean, those are the three key identities here. And you
Like
could
identities?
Identities for.
cofunction identities.
Couldn't you just draw the triangle? Because that's what I did in I thought the right answer is that just like a
Yes, you can. What these give you though is if it's not in a right triangle, like if you have a 200-degree angle. The sine of 200 degrees will be the cosine of 200 minus 180. Or, I'm sorry, 200 minus 90. Or it's also the cosine of 90 minus 200. Alright, so, Alex,
I understand why like pi equals 180, but how, when plugging like equations into the calculator, it'll pi would plug in for 3.14. Like,
yeah,
how is
well,
Would it work?
because, yeah, as long as you're in the right mode, make sure you know what mode you're in on your calculator, whether it's radians or degrees.
which one would you want and then to make it equal 180?
Well, here's the thing, if you're in degrees, you're not gonna use pi.
Okay.
You're gonna use the 180. If you're in radians, you'll punch in pi.
Okay.
So, yes,
Do we have to memorize those three equations?
yes,
Do you have to memorize what? Oh, these?
you should know those,
Can you
yes.
scroll up to the other one?
Because of this, it's not
The quiz is on Tuesday?
What other one?
The complimentary.
Oh,
Mr. Hicks, and the quiz is on Tuesday?
we are having a quiz on Tuesday.
How do you prove each one?
Wait, that's the long period.
Uh, you could look up how to prove it,
Are we reviewing?
but I'm not gonna go through that now just for sake of time.
Are we reviewing
Okay.
before the quiz?
So it's like it's kind of like an
Well, that's kind of what we're doing right
How do you
now.
know
We're
that-
answering questions but we still have some more things we need to talk about too.
How do you know the second equation? How do you get?
Well, that's what I'm saying. I'm not gonna go through the whole development of all this.
Zero.
This one actually is relatively simple because the secant is the reciprocal of cosine and the cosecant is the reciprocal of sine. So if you just took the reciprocal of both sides of this equation, you'd get that.
Can you?
And if you took sine, because sine of theta equals cosine of pi over 2 minus theta, and cosine of theta equals the sine of pi over 2 minus theta, then if you did sine theta over cosine theta, you get tangent of theta. If you did cosine of pi over 2 minus theta divided by the sine of pi over 2 minus theta, you'd get cotangent.
Oh, I see.
So there is a development there, but alright, so getting back to the question that was asked about the homework. If we know this, sine of 30 is automatically the cosine of 60, so the cosine of 60 is 1/2. Okay? If we want to know the cosine of 30, that's going to be equal to the sine of 60, which is root 3 over 2. Okay?
Now for the tangent of cosine, you would do root 3 over 2 divided by 1/2, and then that would be your tangent of 60 degrees, and then you just swap it. Yeah, never mind.
Yeah, for tangent of 60, you just do sine over cosine.
Okay, then you just swap.
Alright? Then down here, here's another example of our cofunction identities. The secant of 90 minus theta is going to equal cosecant of theta. Alright? Because those are cofunctions. Alright?
Question.
Yes.
Can you go up 2 slides? Like 2 slides.
Up here?
Yeah, yeah. Are those all the identities you need to know?
These are all the fundamental ones. Your reciprocals, your quotients, and your Pythagoreans. We're learning more than just these, but they're actually known as the fundamental trig identities.
You'll give us those, or will you be able to?
No, you should know those. So, the nice thing is though, guys, I know there's going to be a lot of stuff to memorize, but we're going to use it so much that a lot of this is just going to become, no-brainer stuff for you by the time you actually get tested on it. So. Alright,
We did, can you go back to the one we were doing?
yes. What other questions do we have?
How do you know the cosine of 30?
It's in the units of
Cosine 30 equals the sine of 60. That's our cofunction identity, so that's.
the interchangeable.
Okay. Any other questions on homework? Oh. This I did want to make sure we touched on here. Okay. I'll show you the first three and then we'll actually do the last one. Okay. Trig proofs are kind of fun, I think. I like trig proofs. It says use the trig identities to transform one side of the equation into the other. And then here, all they're telling us here is that theta is where?
0 and 90.
It's between 0 and 90, it's what?
First quarter.
It's in the first quadrant. So do we need to worry about positives and negatives and that stuff?
It's all positive.
No. Okay, they're all going to be positive. We don't need to worry about anything like that. Okay, so you'll notice here when we're approaching one of these trig trig proofs, we want to prove that tangent times cotangent equals 1. Well, logically that makes sense because remember cotangent is a reciprocal function. Alright, but if you look at it here, we would substitute in a 1 over tangent for cotangent. And then when we do the multiplication, it's just tangent over tangent, which equals 1. Okay? Here, if we're trying to prove that tangent times cosine equals sine, we write the tangent as sine over cosine, then our cosines will cancel. And all that's left over is sine. What? Yeah, it's kind of like a puzzle. You just got to figure out which ones to use and how to rearrange things to get it to look like the other side. 53, how did I get from here to here?
I'll use the
You foiled it.
Yeah, we FOILed it. We just multiplied the two together. Okay, these are conjugates, so the outers and inners cancel out. We just have 1 minus cosine squared. And if you remember our Pythagorean identity, we said you can use algebra to rearrange this. So if I subtract the cosine squared, 1 minus cosine squared equals sine squared. So I'm there. This last one is a little bit more challenging. So we've got some fractions involved, and we've got to take these two fractions added together and get it to somehow equal cosecant theta times secant theta. Does anyone have a thought how we might go about it? Alex, what do you think?
I haven't gotten the whole way through, but sine over cosine, that would be tangent plus cotangent.
Okay. That's a thought.
I made the denominators the same, so I multiplied by sine for the first one, and then I multiplied by cosine on the second, so you can have the equations.
Okay, so you multiply this by sine over sine, so you got sine squared over sine times cosine. And then this one you multiplied by cosine over cosine.
Yeah. And then when you add that, sine squared
equals to
equals 1.
Okay, now hang on. As you guys look at this, notice there are two different ways, and this is where, you know, this is kind of like a puzzle. You might try something and get part way and then realize that you're kind of stuck, okay? This is absolutely right. Tangent plus cotangent. The problem is we're not really going to be able to go anywhere with that, okay? So we try it, and we realize we've got to try a different strategy. Now, the reason why this one might jump out at you a little bit more is because notice we have two different terms added together. But over on this side, we have two things just multiplied together. So we have to somehow get this left-hand side to just be all one expression. All right, and that's going to happen quite a bit with these. Now we can add them together. We get sine squared plus cosine squared over sine times cosine. All right, and you guys are right. This equals 1.
And then that translates
Oh, wait,
to
wait, wait,
cosecant
wait,
and
whoa, whoa, whoa. Oh, is that the Pythagorean?
Yes, this is the Pythagorean identity. Sine squared plus cosine squared is 1. Now, if we separate this, because this is multiplication, we could separate it into 1 times sine of theta times 1 times cosine of theta. That equals cosecant times secant. Okay? Does that make sense to everyone now?
Yeah.
Can we copy the 3 Pythagoreans one more time?
Alright. Did anyone else have a question about the homework?
Thank you.
Alright. Now, we're going to look at today.
Are these notes up already?
Yeah.
They are. Okay. What I want to look at today, there's one more set of identities I want to look at this point. And it's almost more of a relationship even than it is really an identity. But you could call it what you want. But it has to do with the fact that some of these trig functions, or I should say all of these trig functions, are either even or odd functions. Now we're not talking about even and odd as, like 2, 4, 6, 8 or 1, 3, 5, 7. Does anyone remember what even or odd means, or
Like,
no?
if you use a negative number, it will become positive if it's even. Like, if you multiply it, or if you do it, and it's like, if it's an even function, it makes it positive or negative, like it flips the sign.
Okay.
And if it's odd, it doesn't, or something, no.
Okay, it has to do with the positives and negatives in there. We're on the right track.
If it's even, both is upwards, is one upward, one down.
Oh, you're thinking about the
Graph.
what was that called? Yeah, when you're graphing, if the power of x, your degree, is even, then yeah, you'll either go up on both sides or down on both sides. If it's odd, then you'll either go down on one side and up on the other, or up on one side and down on the other. That's true, but that's not what we're talking about here. Okay? It's okay if you don't remember this. This is one of those kind of details that sometimes we tend to gloss over a little bit. But an even function, it does have to do with when you plug in a negative. Okay? If you plug in a negative for x, you get the same result as when you plug in a positive for x. Okay? And cosine and secant are like that. Alright?
Secant is 1 over cosine.
Yes. So f of negative x equals f of x. If you plug in an angle into cosine, you'll get the same thing as if you plugged in the opposite of that angle. So cosine of 50 has the same value of cosine of negative 50. Okay? We'll look at some more examples here below. Does anyone remember what that looked like when you graph it?
Cosine, it started at
No.
That was absolute value.
which part?
Maybe not.
She was saying it looked like a V. Now, absolute value was like this. Okay? Absolute value functions are even. If you remember, cosine looked like this.
Oh,
Yeah.
On the other side, it would look like this.
The secant go from -1 up.
Secant, yeah, those ones, we're going to graph those. It looks like this.
Okay.
And I should be actually hitting those. And on the bottom, it goes like this. Alright. Kind of a strange one. It's got a bunch of asymptotes too. But anyways, what do you notice about cosine? It has, yeah, symmetry. Okay? An even function will be symmetrical across the y-axis. And that's because f of negative x equals f of x. Okay? Now, the odd trig functions are the other four. Sine, cosecant, tangent, and cotangent are all odd. What that means is when you take f of negative x, you get the opposite of what you'd get for f of x. Alright, this one actually looked like a rotation of 100 degrees, or 180 degrees, sorry. And actually you can see that with our sine curve, since we've seen that already. My sine curve goes like this. Watch this, this is kind of cool. Oh, it doesn't erase it. Hang on, that's not cool. There we go. So if I took it, an odd function, it's like it was rotated, it has symmetry about the origin. Which means if you rotate it 180 degrees, it'll be identical. So here I rotated it 180 degrees, and I have the same thing. Okay? In fact, if I rotated the entire thing, both sides 180 degrees, it would still look the same. Okay? So that's what odd is. And I'm not concerned too much right now with the graph, but what does that mean in relation to our sine, cosine, tangent values?
It means
Okay.
you have
Okay.
and
Well, let's look at our unit circle and kind of relate this here. Yeah, did you have a question?
Yeah, what do they even and odd mean?
Don't ask me why they're called even and odd. I have no idea why they're called
What
even
is
and
it?
odd.
What
That's
is the
just the
difference
term.
between the
Even means we have symmetry across the y-axis like this. Okay, those two sides are identical. Odd functions have symmetry about the origin, we would say. In other words, if you rotate it 180 degrees, it'll be identical.
So it's like if you hold the where the graph is on the origin and then you twist it, but
Yeah.
it's still holding that point on the origin.
Yeah,
So it's upside down?
kinda. It's just spun. It's rotated. It's like if we took this and just spun it around like that. Obviously, this is not odd because it's not the same. Okay. Alright, so cosine of theta. Cosine of theta is going to equal cosine of negative theta. Okay? So, according to our unit circle, what's the cosine of pi over 6?
Root of 3 over 2.
Root 3 over 2. Let's do that.
How do you get that on a calculator?
Huh?
How do you get that on the calculator?
You'd have to change to radians and then punch in pi over 6 and then hit cosine. Or you can just look at your unit circle.
Good.
Okay? Which by the time we're done you'll know so well you're not going to bother with your calculator. Okay? So, cosine of pi over 6 is root 3 over 2. If you guys don't already, have your unit circle that we've already done out, because we're going to use that here. Okay? So, if that's the cosine of pi over 6, what's the cosine of negative pi over 6? It's root 3 over 2. Okay, which by the way, that's the same thing as 11 pi over 6, which is one of the points on our, or one of the angles on our unit circle that we're going to look at. Okay? Now, what would the secant of pi over 3 equal? Secant's 1 over cosine, right? So what's the cosine of pi over 3?
2
1/2.
Oh.
2
No.
root 3 over
A
6.
different angle this time, pi over 3.
30 degrees. No, it's 60 degrees.
It's the same as 60 degrees.
It'll be 2.
Secant will be 2, yeah. Cosine of pi over 3 is 1/2. So the secant is the reciprocal of 1/2, that's 2. Alright, so what's the secant of negative pi over 3?
2.
Negative 2.
2.
You pull out. Oh no, it's secant.
It's secant. Cosine and secant.
Hi, excuse the interruption. Please dismiss Alexia Debris to the 400 building at this time.
Alright, she's on her way.
You have a hockey game?
Okay,
Yeah.
so notice for cosine and secant, it doesn't matter what sign the angle has, your value is going to be the same. Okay? Now, for sine and tangent, that's not the case. Alright, let's look at some of these down here. Alright? According to our rule here, the sine of negative theta is going to equal the opposite. See ya, have a good tournament.
Thank you.
It's going to be the opposite of the sine of theta. Okay? So think with me here. What's the sine of pi over 6?
Sine
1/2.
30 degrees.
It's 1/2. Alright? It's 1/2. So what's the sine of negative pi over 6? Negative 1/2. Good. Okay? Negative 1/2.
Why you have the negative sign set in the parentheses?
Well, this here is showing our relationship. If we have the opposite angle, it's going to give us the opposite sign. Okay? And this works this way for sine and for tangent. What's the cosecant of pi over 6? 2. So what's, because the sine of pi over 6 is 1/2,
Oh, wow.
so it's a reciprocal.
So it's negative 2.
Yeah, so the cosecant of negative pi over 6 is negative 2. Okay. This is good practice for us. We're going to be using the unit circle a ton, okay? So you've got to stay with us, stay alert, and really try to figure this out. Again, have your unit circle. We already did the first quadrant of the unit circle, so all this stuff is from there. You should have that out right now and be following along and finding those things, okay? On the quiz on Tuesday, you are not going to have to know the whole unit circle, but you are going to have to know how to use it. If I give you the unit circle, you should know how to,
Oh, that's pretty cool.
if I said, hey, what's the sine of 330 degrees? You should be able to tell me that using your unit circle.
Sounds 750.
But we only use 1/4.
Well, Monday we're going to get the rest, so.
I'll do it. So for Tuesday, should we know it all, or just
You don't have to have it all memorized, no. But you should know how to use it, because the way we'll use the rest of it is exactly the way we've been using the first quadrant.
Sin 360 is 0.
Yes. Alright, so tangent of negative theta equals negative tangent of theta. Okay? So what's the tangent of pi over 3?
It's the sine. It's root 3 over 3.
Well, it's sine over cosine, right?
The root of
And sine is
1/2.
root 3 over 3, root 3 over 2, sorry.
And it's
And cosine is a half, so Alexia was right, it's just root 3. Okay? So the tangent of negative pi over 3 is what? Negative root 3. Okay?
Wait, how is it root 3?
You had to do sine over cosine. Sine was root 3 over 2, and cosine is 1/2. So if you divide, the 2's cancel out, and you just end up with root 3 over 1. Okay. Any other questions? Yeah, Alex?
How do we like instinctively know that sine pi over 6 is 1/2?
Well, we know it from our unit circle, because
Yeah,
it's
I
the
know.
y coordinate.
But I know that 1/2 is the y coordinate, but how is pi over 6? Like, wouldn't that change to 1/2?
No. Go back to your unit circle. On your unit circle, at pi over 6, the y coordinate's 1/2. So that is the sine. All of these points are sine and cosine. Okay? So sine of pi over 4 is root 2 over 2. Okay?
So should
That's
we
why we're learning those coordinates.
Should we memorize the unit circle?
You will have, yeah. And really, once you memorize the first quadrant,
Are those
the rest of it you can very easily figure out. And that's what we're going to look at Monday, developing the rest of it. All right, I want to do one more trig proof. Okay, it wasn't called this on your homework, but when you're asked to show that this equals this, you need to leave that side alone. Okay, you don't want to be working on both sides, and you certainly don't want to take stuff from one side to the other, okay? So we're going to leave the secant alone, and we're going to modify the left side so that it will look exactly like the right-hand side. It'll equal secant, right? Instead of thetas, we used a's, just to change things up a little bit here. So does anyone see something I could do with that?
the sine pi over 2 minus a?
What's that? That's cosine of a. Good.
The original formula is like sine theta equals cosine pi over 2 minus a. Look at the switching.
You can switch those, yes.
The tangent
That's
equals
the
sine over cosine.
co-function identity.
Good. Lexi said we're going to put sine over cosine. You're right, that was a cofunction identity. Okay? Now we're multiplying that by sine. Right?
Sine squared.
So yeah, this is sine squared.
Well, times make it the same diameter.
Good, we want to get the same denominator, so we're going to multiply this. We need a cosine, so we need to multiply by another cosine in the numerator.
It's 1 over cosine.
There we go.
Set.
Does everyone follow up to this point?
Wait, how do you get rid of the sine squared again?
It's 1 over cosine
Wait, we
So
got
it's
the
equal
sine
to C.
squared by just multiplying
Yeah,
this
but then
together.
your answer is 1 over cosine A equals.
Yes, and we're gonna do that because now that we have a common denominator, we have sine squared plus cosine squared, which equals
1
1.
Okay.
So that's 1 over cosine,
secant.
which is secant. Okay. Alright, so I wanted to throw in another practice with that.
Mine has it.
And the last thing I want to look at in the few minutes that we have left, one other application of all of this is actually using the trig in real life, okay? And this is one thing, especially those of you who are not, who English is not your first language. I will try to avoid this as much as possible, but you may have to look up some things. For instance, we read this problem here. It says a 30-meter line is used to tether a helium-filled balloon. Because of a breeze, the line makes an angle of approximately 75 degrees with the ground.
You mean like that?
So yeah, and here's the thing. Even if you don't know what tethering is and helium is, okay, if you don't recognize those words, you still see the word ground, and you see that there's a line that's making a 75-degree angle with the ground, and you know that that line is 30 meters long. Okay? Now, what does the word tether mean?
Propels.
It's to hold, to attach.
Connect.
Attached or connected to. Have you ever played tetherball?
Yeah.
You have that pole in the ground that's like 8 feet tall, and there's just a ball and a rope that's tied.
Oh,
Yeah,
yeah,
it's a
spins
really
around.
pointless game, I thought, but
It's fun.
it's fun at camp or something. But anyways, we got this balloon, all right? Got this balloon, and it's tethered. It's tied to the ground by this 30-meter long line. Okay. Now, right there, what we just did, and especially here it's saying use a variable to indicate the height of the balloon. If I'm measuring the height of the balloon, how am I going to measure that?
So
It's like a vertical.
triangle. Right triangle.
Straight down, vertical line, okay? So I'm making a right triangle here, and we can just call that H if we want. But right there, that's 75% of the problem, right there, is getting a picture to help you see what's going on. And now you can do parts B and C, all right? Does anyone have a question about how we drew this or whatever? Now, I have 2 warnings, okay? To those of you who are not artistic at all, don't worry about it, okay? Don't worry about it. Your drawing does not have to mimic real life. Okay, so that's the warning to those of you who are not artistic. To those of you who are artistic, don't get carried away. I've had students who have drawn these really elaborate drawings and they spend half their test time making cool drawings and never actually solved the problem. Okay, so just be careful that you don't get carried away. You could get it, when you get the test back, you could elaborate on your picture if you really want to. Alright, but just make it a simple diagram and then solve the problem, okay? If we're going to use a trig function to write an equation, how would we do that?
Sine of 75 degrees equals H over 30.
Someone else, why did he use sine?
Or cosine.
Because opposite.
Yeah.
So
Okay. You got to look at what you're given and what you're trying to find. We're trying to find the opposite side. We're given the hypotenuse. Which trig function uses opposite and hypotenuse? The sine. I'm not sure why this isn't writing for me. Okay, that should be over 30.
What time
Okay.
we use the radian or what time we use the
Oh, yeah,
degree?
right.
Oh, it crashed on me. Let's try opening that back up.
Just update the.
What time do you use radian, when do you use degrees? Basically, if it's a word problem, just go with whatever they give you. Or look at the directions. The directions, sometimes they'll say, you know, find theta between 0 and pi over 2. So obviously they want you to use radians, okay? But they say find theta between 0 and 90, they want you to use degrees, okay?
You update the system, right?
So, I'm not sure why
Oh,
it
you updated
crashed,
it?
but
Wow,
Anyways,
it is
what did you
always
update?
fresh.
Yeah.
I did an update to
It is.
Yosemite.
如果它是
I mean,
let's
yeah,
reopen
Why is
that.
that tune's red?
不是它本来
Oh, it's been red for a long time.
My tune's been blue for 4
Um,
years.
alright, are there any questions about that? I know we didn't get
To find H,
Finish.
would you use like,
如果它是原来
Hang on.
What?
how would you find H?
to find H. Yeah, let's recover that. Well, you have sine of 75 equals H over 30. So you would just undo division by multiplying by 30.
Okay.
The one thing I will say to be careful about, oh, here it is. Is when you do the multiplication on your calculator, I would start with, oh, it's open all over. I would start with sine 30 equals, and then, or 75 equals, then times 30. Okay? Alright. So,